they only have the launch auto sequence maybe in the last 4 minutes, 5 minutes or so. For example, Electron, I think it's at T minus 2 minutes. Atlas, it's at T minus 4 minutes or something like that. So it's very different between rockets. Falcon 9 is completely automated. That fueling sequence, it's all automated.
Right. And then the control of that countdown switches from ground computers to onboard the vehicle at T minus 1 minute in the event that is known as startup. Also, at that time is when the vehicle tanks begin pressurization for flight. A little before that, uh, anytime now, they will begin engine chill of the 9 Merlin 1D engines on the first stage. That's when they flow a little bit of liquid oxygen through the turbo machinery to make sure, just as they cool down the line before stage 2 liquid oxygen load, they want to chill down the engines before stage 1 ignition at T0. Um, then,
I
hopefully,
believe I'm seeing.
Yeah, update here.
Yeah. So we've had the clock stopped and then it recycled to T minus 15 minutes. That's the usual sign that they are essentially in an abort. I also saw on that feed that we just had Falcon 9 venting out, so that was probably the depress vent, just like we see also a Starship when they abort the count. Um, so yeah, it kind of looks like we're
Yeah.
in a scrub.
And even if you reset it to 15 minutes, when you think about it, there's minutes left in the window,
Yeah,
so there isn't time.
yeah, and I know a lot of people usually get confused about that. That's normal. I was saying before, this is a launch auto sequence. This is completely automated, right? That's part of their automated sequences. On that automated countdown, when it aborts, then the clock automatically reverts back to T minus 15 minutes, and then all of the processes, all of the drain back starts to drain all of those propellants from the rocket. But yeah, this is an abort due to winds, as they they are mentioning. But yeah, kind of sad. Try again
so with
tomorrow.
that, yeah, I was just about to ask when the next launch opportunity is. It is tomorrow at basically the
Oh!
same window,
That's a
correct?
hold. That's
Same
okay.
window.
Another Rosendem.
And
Another
weather,
Rosendem.
Same.
Hold on.
actually,
Hold on.
Weather is worse
What a
tomorrow.
tease,
yeah,
dude.
Yeah,
weather
that's
is
that's
What a
45%
tease,
go.
man.
yeah.
Yeah, by the way, for those wondering, it is literally the exact same concerns in terms of weather conditions for tomorrow's attempt, although again, at 45% go because of liftoff winds, cumulus cloud roll, and lightning roll. However, in addition, the upper level wind shear, which was already at low to moderate today, you then get the addition of the booster recovery weather becoming low to moderate as well.
Yeah, I should also mention, because someone brought up this on chat, and they are true with this, that yes, the countdown is automated. The abort is not automated. So if the operators, so the abort in this case, because it was for winds, it was manual. The operators can have manual control of an abort up until T minus 10 seconds on the count. So it was essentially a command, manual command, but that manual command just transitions the automated countdown sequence to a automated scrub sequence, so to speak. And so they just essentially the computers transition to that drain back state, and so the ground systems, the rocket, and everything all transitions into that. It's also automated as well. Um, it's very nice because that means there's not a lot of people having to control a lot of buttons and a lot of valves and whatnot. It's all automated. The whole software does that thing, and so that's good.
Right. Yeah, it's just been the weather in Florida, as Sawyer has been saying, has just not been ideal, and unfortunately, SpaceX hasn't been able to get a launch off. But don't forget, there is another launch later this evening from the other coast, the best coast, as Jack would say. Starlink Group 9-1 will be launching 20 Starlink satellites into low Earth orbit, 13 of which have the direct-to-cell capability. So we will not be live streaming that, but at least SpaceX will hopefully get a launch off the ground. Anyway, I
Yeah,
think
and
that
again,
is. Oh, go ahead, Alex.
oh, sorry. Well, I was gonna say the the window for tomorrow is very similar. It is at, instead of 5:38, it is 5:25 p.m. Eastern time. It essentially goes for another 2 hours and 49 minutes. As always, you can use the
What
Next
up?
Spaceflight website and app and everything.
Hey, what's up?
That'll keep you updated. And of course, we're also going to be live tomorrow as well. So, yeah.
Yep. We will be back tomorrow. But with that, we want to thank you all very much for being here today. We really appreciate it. And I also want to thank the fellow voices you heard today, starting with you, Alex. Alex, thanks for all of your insights and commentary as always.
So they were supposed to launch, but they scrubbed it.
It's been a pleasure, and hopefully we get this Falcon 9 off the ground tomorrow.
And then, of course, we had Sawyer out in the field. Sawyer, thank you very much.
My pleasure. It's a lot more of a pleasure when it actually launches, but nonetheless, you get to have a great day out with rockets and good people, including D, who they have been working super.
A space?
System to enable SDDM.
Oh, by the way, system CTL is very badly pronounced. I don't know how you would fix that, Leonard Pottering. But maybe system... I honestly wouldn't mind it being system control.
System control.
And then you'd be able to know that that's the system control command for system D. Which would be interesting. It's a few extra key presses, but for screen reader accessibility, that's amazing. Amazingly worth it. I didn't even think about that till now.
What's this?
But the point is, there are lots of techniques you can use to make sure that things are readable for people who struggle with visual impairment and even dyslexia, because the blind aren't the only people who rely on screen readers. Sometimes you struggle to read and want something to be read aloud, and it would be very nice if the things being read aloud were read aloud correctly. And I'm going to make the case that, well, you heard it earlier, putting artificial intelligence and clouds and all that crap in front of the blind and screen reader users, using the internet and the cloud to solve that problem, it's all in vain because, well, we heard it earlier.
At Acidic Light, I'm talking about posts on Mastodon. Many people will write hashtag #KDaPlasma amazing, but your screen reader, I imagine, doesn't pronounce that correctly. Instead, hashtag KDE Plasma is amazing would be read correctly, right?
Yeah, you heard it. And to prove that this is the internet reading that, and this is the other reason why I feel like these cloud-based text-to-speech engines are horribly implemented, I'm gonna stop Network Manager. I do not have internet right now. I misspelled system CTL and I forgot a sudo, so, I no longer have internet right now. If I try to read what Justin said through the text-to-speech engine...
At Acidic Light, I'm talking about posts on Mastodon.
it got cached.
Many people will
Or
write
maybe I still
hashtag
do have internet.
#KDaPlasma amazing, but your screen reader, I imagine, doesn't pronounce that correctly. Instead, hashtag
Where's it
KDE
pulling
Plasma
it
is
from?
amazing would be read correctly, right?
I don't have internet. I swear I don't have internet. I shouldn't have internet. I still do have internet for some reason. IPA. Okay, I'm really gonna knock out my internet. IP link ENP6S0 set down, I think. It's not EMP, it's ENO. I do struggle to read that. What is it? It is definitely ENP6S0, so clearly I misread or mistyped something. Or is it? Okay, this should not be troubleshooting manual networking commands video, but now my internet should be down. And I can't resolve hosts or anything like that. If I try to read what Justin said when my internet connection is non-existent or slow, or it just can't connect to Google servers, I'm not reading that text. So that's why putting cloud shit putting cloud shit as a solution to text-to-speech engines mispronouncing things is all in vain, and just makes things even worse for us blind people, because sometimes you don't have internet and you need to read your screen to figure out why. I'm gonna bring my internet back online, and sudo systemctl enable --now network manager. There we go. Just to make sure I do have continuous internet access. Great. So yeah, with that in mind, you need to consider the fact when you're naming things that a text-to-speech engine is going to mispronounce it if you don't use proper casing. So, hopefully this video gives you a nice little demonstration on basically naming things and how that can go wrong for the visually impaired or dyslexic or anyone else who oh my god, I can't talk, who relies on a text-to-speech voice. And how I think that local TTS engines, for all the flack that they get for mispronouncing things, it's not their fault. It's just that content needs to be authored in a way that screen readers can handle. And you know what? The cloud-based ones are no better. And are in fact even worse because you need internet to use them. So yeah, that's gonna do it for this video. As always, I hope you learned something. My name is Michael, even though everyone calls me Richie. If you like what I do and you want to support it, and you know, I know I stutter a lot, but if you like I can't talk, seriously. If you like what I do and want to support me, there's a Patreon link in the description below. And if you want to catch up with what I'm doing on this YouTube channel, there's a subscribe button that I can't pronounce. And you know what? Other than that, I hope you learned something, hope you enjoyed the video, and I'll see you guys in the next one. And I hope this answers the question, Justin, because yes, the way you name things and the way you use capitalization in names and punctuation is very important, as we've seen in this video. So yeah, see you guys in the next one. Bye guys. Still haven't figured out this Stream Deck. It's kind of embarrassing. Hey everyone, I'm Michael, and welcome to another video. And I am very glad that Pet the Hawk is my desktop wallpaper right now, because he is my good luck charm, and I have just made something incredible work. I want to show you guys it. So, I'm on Linux. I have been on Linux for months now. I still use Windows from time to time, but most of the time it's in a virtual machine. I am a Linux user. And I don't intend to change that. I despise Windows. I hate it with passion. It is the worst thing that has ever been created nowadays, especially with Windows 11. And I just don't want to use it. So, I'm going to use Linux. But, Linux is not without its issues. Not all pieces of hardware support Linux. And one of those pieces of hardware would be my Stream Deck XL. I bought that back when I ran Windows, and I used it to control OBS and media and all of that wonderful stuff that I really don't want to use the UI to control. I am blind, so using a user interface, not the most fun thing. I would rather have a hotkey or some sort of physical input that I can press, memorize the location of, feel around for. and do something with. And particularly with OBS, even if I was not blind, I want that anyway. Because when I'm recording a video, well, I'll just show you. If I want to stop recording this without a Stream Deck, I would either need to have some really complicated hotkey, because I don't want to accidentally hit it. So it needs to be something I have to purposefully hit. So like a Control-Alt-Shift-R or something like that. Or I could use my Stream Deck. Or if I didn't have that, I would have to do zoom in and, you know, have this happen where you're seeing the screen, and then I have to press the stop recording button. You know, that's not really ideal. Even if I weren't blind, I could do it without zooming in, but because I'm blind, it's exacerbated because now I have to zoom in to find the button, and then you guys see OBS, which is not ideal. So that's why I bought the Stream Deck, so I could wire it up to the stop recording button, or the start recording button, or whatever other action I want to perform in OBS. But that only works on Windows and macOS, because the Stream Deck software only exists on Windows and macOS. And maybe you can get it working under Wine. I don't think anyone's done that. The big benefit of using the official Stream Deck software is you get the OBS integration plugin, but on Linux you don't get that. There are third-party Stream Deck drivers. In fact, I'm using one, but you don't get that OBS integration plugin. So it's like very annoying to control OBS because suddenly you have to set up hotkeys anyway, and then you have to program them into the Stream Deck, and that's just not something that I want to do. Then I realized, I'm a programmer. I can solve that problem. And I have. Let me show you. I open up a terminal, and bring it onto this monitor. And I'm going to zoom in. So say goodbye to chat, you're not going to see him for a little. You know, we have this pretty bog standard terminal. But interestingly, what I have done is we go into /opt OBS CLI. A little ls-lart on that to list its files out in a nice display. This is a .NET application. So it's written in C#, but it's cross-platform, because .NET is cross-platform now. And what this is a command line interface that I wrote. It's in my path, so I don't need to be in this directory. For controlling OBS at the command line. Now it's very limited in functionality right now. It has only existed for like 2 days. And I wrote it, so the code's probably not the greatest. But for what I needed to do, it is mostly feature complete. So just looking at the help output here, you can do a -H for the full output. I don't know if that'll show anything too different. No, it won't. Not sure what happened there. But, you know, it'll tell you what you can do with it. So, for example, recording, I guess we do a -H here. It'll give you some more help on recording, but honestly, it's just better to run the command directly and have it do the automatic output, I think. And, you know, what I can do is I can get the recording status, I can start, stop, toggle recording, I can pause, I can resume, I can do all that fun stuff from the command line that you would normally have to do either from within OBS's user interface or through a hotkey. This is really great, because what I can then do is I can go into Stream Deck UI, and this is my Stream Deck right now. So a lot of these commands don't exist yet, so I've set them up for future use. But if I click on record, you can see under the command section, it actually should have the OBS CLI command for toggling recording. So I press that button, and it'll end recording. Now this is an open source project. It is open source on my GitHub. I'll have a link to it in the description. And I could definitely use some help. But some of the things you can already do is obviously all the recording stuff. You can toggle recording, start recording, stop recording, pause recording, resume recording, toggle wherever recording is paused. You can get recording status. So you can figure out if it's active, pause, you can see how long the recording's been gone for, and all that wonderful stuff. But you can also, I'm working on audio control, so I can have a mute and an unmute button for my microphone and stuff for my Stream Deck, which will be useful for live streaming. That's not implemented yet, but you can still list the inputs. Now, there's something weird with the protocol that it uses. For some reason, even though the inputs command is for audio devices, actually inputs are not just audio devices in OBS. Inputs are anything that can be recorded. So, there's a screen capture in the list of audio devices. I haven't figured that out yet. But, you can see there's the microphone and the desktop audio in there. But eventually it'll be something like OBS CLI inputs mic / aux and then mute to mute it or something like that. But that's not a command that exists yet. But you can also switch scenes. I don't have any scenes to switch to, but first of all, you can list them. OBS CLI scenes list. And there's the one scene that I have. Eventually, I'll have one for my left monitor, one for my right monitor, one for my capture card. Haven't gotten that far yet, but that's what those buttons on the Stream Deck are supposed to do at the bottom. But if you want to set the current scene, I don't know if this will work. You run that, and it'll go ahead and switch to that scene. Now, obviously, I'm already on that scene, so that's pointless. But, you can see how that could work. So it's really handy. So hopefully you guys find that interesting or cool or something like that. I think it's going to be really useful. Now, there are other OBS command line interfaces. I'm well aware of that. But they target an older version of the WebSocket plugin. So I don't think that they necessarily work by default. And if they do, because they're targeting an older version of the plugin, it's going to run in some sort of compatibility mode, and eventually that compatibility will be dropped, which is not ideal. But mine targets V5, which is the current release, and it's also built into OBS Studio. So as long as you have the server enabled, my tool will work. And OBS obviously needs to run, but obviously, if you want to use OBS, you're going to have it open anyway, so, you want to be able to see what's going on, right? Anyway, now there are other use cases for this. For example, let's say we're running Windows. How polite of Policy Kit to hide the password entry screen from that monitor. It's shown on the wrong monitor there, that's weird. But, let's say we have a Windows VM, and, you have your Stream Deck plugged into that VM for some reason, but you want to be able to control OBS remotely on your Linux host. Well, you can do that. That is a thing you can do. By just running OBS CLI on the VM and then telling it to point at your hypervisor host. You can do that. Don't know why you would, but someone out there will. So, I implemented the feature. For some reason, Windows is not starting. I don't know what's going on there. I'm gonna have to investigate that, but weird. I'm gonna debug that off camera. Anyway, hopefully you guys find that useful or interesting or anything like that. With that said, as always, I've been Michael. Hope you enjoyed the video. Hope you learned something, and we'll see you guys in the next one. Thanks for watching.
This is the restoration of the PCs Limited 286. Michael Dell started PCs Limited in 1984 and quickly achieved success before changing the name to Dell Computer Corporation in 1987. We acquired this system from a nearby auction without any idea of its history, its condition, or even where it came from. The PCs Limited 286 is an IBM PC AT compatible. It debuted in 1986 and was praised for its build quality and performance, with a 16 MHz version even outperforming some 386 systems at the time. We first wanted to remove as much dust as possible from this nearly 40-year-old system. Well, that noise does not sound good. And off camera, one of the tantalum capacitors actually exploded. This is not uncommon, and thankfully they rarely fail in a way that damages other components, unlike what can happen with electrolytic capacitors. The clicking noise sounds like it could be the overcurrent protection in the power supply. So let's get started on the disassembly. This battery holder contains 3 AA batteries. These holders are commonly used to replace the original CMOS backup batteries on old motherboards like this one. The first card we remove is labeled Talker on the case, and with a DB25 interface, RCA jack, as well as an onboard speaker, this is a vocal synthesizer board. And it's from 1986, so possibly original with the system or installed very early on. Next is the VGA card with an Oak Technology 087X chipset. These systems originally came with EGA video cards, so this was upgraded at some point during its life. This is a 14.4 kbps dial-up modem with a 1994 date code on the Rockwell chipset. Next is a serial and parallel port controller known as a mini I/O card, provided by PCs Limited as a factory option. And finally, the SCSI and floppy drive controller, which also has a 1994 date code on the NCR chip. The large and heavy MFM drive by Computer Memories Incorporated is removed. This did not have power connected to it, and no controller card is present, so we're not sure of its condition just yet. The 5 1/4 inch floppy drive is made by Mitsubishi. And that's followed by a Sony 3.5 inch drive with a build date of July of 1994. And lastly, the Corporate System Center SCSI hard drive, likely manufactured around 1993 or 1994. So the system most likely had an upgrade around that time. The motherboard is based around the Chips and Technologies CS8220, the chipset that actually introduced the term chipset. Let's take apart the power supply. It's dusty, but the capacitors all visually look okay. Not sure why there's electrical tape on the fan wires, but that may mean that this fan has been replaced before. We're testing the supply with a 4 ohm load on the 5 volt rail, as switching power supplies like these typically need some sort of load in order to regulate their output well. Our 12 volt line is slightly high, but otherwise the outputs look fine. And the fan sounds great, so no need to replace that. Since the supply is dirty and the electrolytic capacitors are pretty old by now, we opted to replace them, which will also give us a chance to use the ultrasonic cleaner to make this board look brand new. We're removing all the components we don't want in the cleaner. As suspected, this fan has been replaced before with a not so great job at splicing together the wires to the original connector, so we'll cut that out and do it properly. And the clean power supply board looks fantastic. Now it's just a matter of replacing all of the removed components and installing the new capacitors. Checking the outputs again, our 5 volt and 12 volt are now a bit better, but the negative outputs haven't improved. That may change with a higher load though, so we're not too concerned about that and we can carry on. And with the power supply refreshed, we can move on. Along with the exploded tantalum cap, there's also some green corrosion on the motherboard that we'll need to remove. After replacing the caps, we use a baking soda and water paste to neutralize the corrosion. It's pretty cool to see it working in action here. We had to remove the components in this area to make sure we got all of the corrosion, which had gotten below some of the solder mask. After reinstalling the removed components, we apply a dab of clear nail polish to protect the exposed copper. And finally, we rinsed the area with deionized water to get rid of any lingering baking soda. After cleaning up the case, we can start reassembling the computer. Our first power on though shows we're still having an overcurrent issue, likely coming from one of the cards. Only the vocal synthesizer, modem, and I/O cards have tantalum caps. Since we've had issues with those, let's remove those cards to see if the issue resolves itself. This is great progress, so now let's try reinstalling the cards one at a time. The I/O card is definitely faulty, but let's try the vocal synthesizer. Well, that was dramatic. Let's watch that again in slow-mo. And here's the aftermath and what's left of the two plates in the capacitor. Checking the tantalum caps on the I/O card reveals two of them are indeed shorted, but we'll go ahead and replace all of them. With any luck, we should be back in business. Looks like we have all of the issues resolved, so let's reinstall the drives. And if you'd like to see the full process from start to finish, check out our second channel, the Parallel Port, where we posted the nearly hour-long repair video. With the computer reassembled and back to life, we boot into IBM DOS. One of the main uses for a system like this in the late 80s was to dial into local BBSs, so we installed the Terminate terminal program. Terminate was developed in Denmark in 1992. It has an incredible install sequence complete with a prize drawing entry form, as well as the flow of information animation. It packed a ton of features, including the ability to fax, play music CDs, as well as host its own BBS. After the installation finished, we dialed into the Dark Realms BBS, which was originally established in 1994 in Toronto, Canada. It's running Renegade, our favorite BBS software, which is still in active development. Dark Realms is particularly significant, being the North American hub site for FidoNet, a distributed message network developed in the 1980s for BBSs. We hope to dive into FidoNet and related technologies in later videos. And one of our favorite games from this era is Legend of the Red Dragon, a text-based RPG door game that was found on thousands of BBSs in the 90s. There are a few issues still left to address on the PCs Limited, as we're still only seeing 512 kilobytes of memory during post, despite this board having just over 1 megabyte installed. And we actually did get the MFM drive to wake up, and as expected, it's very loud. More importantly though, this system is now back in working condition, giving us a glimpse at the pinnacle of personal computing in 1986. And don't worry, we didn't forget the voice synthesizer.
Thank you for watching the COD port.
That's right, on March 12, 1989, the web was designed.
There was a time before Google, we all remember it.
One danger is this could turn out to be an elitist system, one available only to people with a computer and a modem.
Imagine this. Take away the entire concept of the World Wide Web. No websites, no social media, no Google. There is no directory, there are no signs, nothing to guide you. There's nothing but a text prompt. So what do? Where do you go?
Area. And if we do a directory, we'll see it has a whole bunch of stuff, the US budget.
The internet in the late 80s through the early 90s was a revelation for those new to it. But aside from the struggle of actually getting online, the next problem people encountered was simply navigating their way around. This was definitive of the internet experience and had been characterized as an exponentially growing mass of poorly classified data. And it was rapidly growing. In 1984, the internet had about 1,000 hosts in total. And in 1987, this had increased to 10,000. But by 1990, the number of hosts stood at more than 100,000. This growth began to expose a weakness of the internet in this era, a weakness that would come to be defined as the resource discovery problem. When a new resource like an FTP site was connected to the internet, there was no real way for users to discover it on their own, and this posed a serious problem for many users. A large part of experiencing the internet at this time was simply knowing which FTP sites hosted the files you needed, or what systems you could telnet into to access a service. And this was often found out by word of mouth. Ed Kroll and the whole internet said this even amounted to a, quote, good old boys network, with some experienced users gatekeeping the best places to find resources like software. And at this time, the internet was still primarily used by researchers and academics, with very little commercial traffic.
Universities were, most, especially the bigger universities, were all, basically all on the net. And there were corporate research labs that were on the net, and then most other corporations were not.
That's Mike Schwartz. He was one of the first to really recognize and investigate the emerging resource discovery problem.
Because I remember when I was in grad school, as I was finishing my thesis, people were starting to talk about it, and some of the grant proposals that they were working on, no one was really working on it yet, and so I started focusing on that, and I think my work was really popularized the term.
Schwartz recognized that solving this problem was the key to unlocking the potential of the net.
The idea of being able to search through all this stuff, in one place across administratively decentralized, organizations, that's really pretty different from like at the time, like a card catalog at a library. There were online, there were computer systems you could search the library books, but you're basically searching the library books at that library or maybe a group of libraries that had banded together. But it wasn't like, you're searching all the resources at different companies and universities and all different people who had basically no administrative relationship all put up. That was pretty different and new and interesting. And also at the time, I guess the other thing I would say that made it pretty interesting is that was when all the bulletin boards and, like Usenet was really getting pretty big at that point. And that was also quite different from like, what were the communities you had available to you, the people you worked around, or people you knew, that you were in physical proximity to. And all of a sudden now there was this way you could reach out to people with common interests all over the world. That was exciting, different.
Schwartz started the Networked Resource Discovery Project in 1988 while at the University of Colorado in Boulder. The idea was to investigate a number of different techniques on how decentralized systems of resources, like the internet, could be searched.
And I remember trying different things. I mean, some of what I did was searching other resources since obviously the web wasn't there yet. So, like I had one project that was trying to search for computers in the local network, and try to build maps of that. And then another one for searching for people out on the internet. And then another thing I tried to convince my university at the time to let me put their information about people, all the different faculty and staff, up online so it could be searched. And I remember I went through this formal process. At the end, they said no, which, now it seems ridiculous. I was just interested in I don't know that I thought that was going to be some groundbreaking development, but let's try it. Like, obviously down the road, things going to be online. Let's start moving that direction.
Schwartz's research and experiments were pivotal in illuminating the fundamental challenges of resource discovery. And there were other ongoing efforts like the X.500 standard that sought to impose a more rigid structure to resource discovery. But the core problem still remained because you had thousands of hosts already scattered across the internet hosting hundreds of gigabytes of data with millions of users, and all of which was organized in its own unique way. And so it was that sandbox nature of the internet that came with a seemingly insurmountable challenge. How do you index all of that so people can actually find it? Hailing from the small Caribbean nation of Barbados, Alan Imtage was enrolled in his third year in the computer science undergraduate program at McGill University in Montreal, Canada. The year was 1986, and the college was just then getting its first connection to the internet.
McGill, from what we can tell, had the second internet link into Canada. The first being University of British Columbia, UBC. I think that was 2 weeks before McGill. We had a VAX machine, which was connected to a modem running at 9600 baud, and it connected to Boston.
After finishing his undergraduate degree, Imtage then continued at McGill as a graduate student and was working in system administration for the School of Computer Science. He became the go-to guy for finding software on the internet, which he found on anonymous FTP servers. FTP, or File Transfer Protocol, actually had its start all the way back in 1971, prior to even the invention of Ethernet. The protocol was developed by Abe Bouchon and his colleagues at MIT's Project MAC, the Project on Mathematics and Computation. The goal back then was to develop a protocol for systems on the ARPANET to exchange files, but it wouldn't be until 1985 that it would eventually evolve into the protocol familiar to us today. Through the early 90s, FTP was a dominant service, accounting for just over 50% of the data traversing the NSFNet backbone in the United States. This was due in part to so-called anonymous FTP servers. These were FTP sites typically hosted by universities that allowed anyone on the internet to log in and access their contents. They would often contain archives of everything from software, literature, scientific research, and everything in between. And it was all freely available. They were a critical resource for users on the net at the time. But because there was no way to search for FTP sites, when you wanted to find information on a topic or maybe a specific software program, you had to rely on hand-curated directories like these, or, like we described earlier, just by word of mouth. This was a central problem for users on the internet. And even though Imtage knew of many different FTP sites, it was still time-consuming to connect to each one, list out the directory contents, and find the file he was looking for. And this is exactly what the resource discovery problem was, because you had all of these anonymous FTP sites scattered around the globe, and each had their own unique collection of software, and the contents could be changed regularly. So programs could be added or removed, directories could be created or changed, and even for advanced users, it quickly became an impossible task to keep track of it all. So Imtage wrote a basic shell script to fetch the directory listings of FTP sites that he frequented, using the command ls-lr. The L option specified a long format showing the file permissions, file size, and so on, and the R option specified a recursive listing, listing the contents of all subdirectories. He ran the script overnight, as that ended up being faster as the site usage was much lower during the evening hours. The following day, he could then parse through the directory and file listings at his leisure, searching for the files he needed without needing to manually connect to each FTP site. This caught the attention of a manager also in the system administration group, Peter Deutsch. They then enlisted the help of their colleague, Bill Heelan, to give the script a simple interface so that others could use it elsewhere on the internet. But first, they needed a name. They decided on the play of the word archive by removing the V to make Archie. And at first, it was a very simple process.
Basically, all we did was issue a recursive directory listing of that directory. And then we pull that back, and ultimately it was a database and all that kind of stuff. But initially, it was just one big file for that host.
In the Archie script and interface, we're running on a Sun 4280 owned by the university.
We hijacked it. We didn't tell anybody what we were doing with it, and we just hijacked. Well, I mean, we were assistant men, so we had access to it. We allocated it.
With the hardware secured and the software given an interface, a Usenet post by Deutsch on September 10th of 1990 was one of the first announcements of Archie to the public. Users could telnet into the Sun server at quiche.cs.mcgill.ca, log in as Archie, and query the latest FTP file listings using the prog command, which would launch a grep command with a specified search string. The return results would show any matching file names from Archie's database, along with their directory location on the host where the files could be found. And as word spread about Archie over the next few months, the telnet traffic to the server skyrocketed and ended up accounting for half of the internet traffic in eastern Canada. What started out as a simple shell script turned out to be the world's first search engine.
Archie had been around for a while, several months, and our School of Computer Science, the director, who was a very proper, buttoned-up Italian gentleman, went to a conference or some meeting of his peers, and somebody came over and shook his hand and said, "Oh my God, thank you for providing Archie. It's an amazing resource." And he had no idea what I was talking about, but being the diplomat, he sort of nodded and said, "Oh, you're more than welcome. Glad to be of service." And then came back to us, hauled us upstairs and said, "What the hell are you guys doing down there?"
That makes me very angry.
After graduating from McGill, Imtaj and Deutsch attended their first IETF meeting in Santa Fe in 1991, and they immediately found themselves plunged into the exciting world of internet standards.
You would go to the IETF and hang out with Vint Cerf and Bob Kahn and all of these foundational pioneers of the internet. They were just there, and then the user layer came in. So Tim Berners-Lee was in
domain
that,
expansion,
and, Bruce
testicular
McHale
torsion,
for Waze, and Mark McCahill for Gopher. And so it was kind of a logical thing that because we were operating at that level, that somehow we should be involved in the IDF. Not so much to standardize Archie as such, but because this was the up and coming area of the internet, and we wanted to be a part of it, and they wanted us to be a part of it.
And it was around this time that Imtaj and Deutsch decided to commercialize Archie by creating Bunyip Information Systems. They would sell software licenses to Archie primarily to other universities and organizations that had an interest in running an Archie server.
Bunyip was, as far as we know, the first company in the world that was specifically created for internet information services, as opposed to just providing networking access, for example. I mean, there were companies that were providing internet services, but not at that layer, not at that level.
And despite commercializing their product, they did not patent the technology.
Vint Cerf said to us one night, I believe in a bar, have you guys thought about patenting it? And he said it as kind of a joke because remember, there was a pretty good period of time there where commercial activity wasn't allowed on the internet, which kind of sounds weird to say that now, but when it was the NSFnet, when the NSF was paying for it, commercial activity wasn't allowed. We honestly did think about patenting the process. Decided not to do it because we figured, again, in this whole environment of we're all in this together, we're all trying to make the world a better place, we're all trying to move the ball down the field and get this thing up and get this baby up and running, that it was going to have a chilling effect on the nobody else had done it. There was no other patented stuff like that out there.
And through the mid-90s, Archie exploded in popularity. It was one of the core internet services users needed to know, along with other early search engines like Veronica and Waze. And at its height in 1996, Archie servers were indexing thousands of FTP sites, collectively containing over 5.7 million files, representing hundreds of gigabytes of data. There were 60 Archie servers located in over 20 countries around the globe, separated out into 4 regions. Archie was everywhere, and it was so critical to daily internet life that it was found in pretty much any internet book from that time period. and even featured in training videos for new internet users. But in the background, the World Wide Web was quickly gaining popularity. The web's Hypertext Transport Protocol, or HTTP, supported file transfer, enabling even easier file downloads compared to FTP. And the concept of hyperlinks made resource discovery that much easier. But even the people there at the time were surprised at how quickly it took off.
The Internet Engineering Task Force meeting, I think it was in 1990, when Tim Berners-Lee got up and made a presentation about the web. So it was this new thing. And I remember I was standing in the back talking to some of my buddies going like, we've got Archie and Gopher and Waze and whatever else. Like, what do we need this thing for? And I just think I did not understand, as I think a bunch of my colleagues also didn't really appreciate, the monumental change that it was to have this graphical user interface.
As the World Wide Web became the predominant information platform, Archie servers began shutting down. Imtaj had already left Bunyip by 1996, and the company itself persisted until 1999 before closing down for good, effectively ending all support for any remaining Archie servers.
I just burnt out. I was traveling 150,000 miles a year, living out of a suitcase, and it was hard to do it in Quebec at the time. It wasn't really a center of technology development. So, the money was all in Silicon Valley, things that were much better funded, and it had much more access to talent. And, so it was in the wrong place at the wrong time to sort of keep growing. And so, ultimately the sort of world passed it by. So
by this time in 1999, the giants of World Wide Web search like Alta Vista, Lycos, and Yahoo had been operating for years. The world had moved on, and Archie, the pioneering project from a university student, had all but vanished from the internet. And today, it has completely disappeared. That got us thinking, why don't we try to resurrect an Archie server? I mean, what better way to honor this world-changing technology, not to mention FTP's now 50-year legacy, than to use Archie to index anonymous FTP servers that are still out there on the internet? But first, we need a copy of Archie. And little did we know, but we were about to embark on a months-long journey.
there was one client that we were forbidden by law to actually talk about. I suspect 30 years later they don't really care, but there was let's just put it this way, some of the intelligence services, let's just put it that way. Yeah.
Today, we're continuing our quest to bring back the world's first search engine called Archie. This once prolific service critical to users of the early internet has seemingly vanished without a trace. So join us as we go on an epic journey to find and resurrect the search engine that started it all. Archie is gone. This once prolific service of the internet has vanished. There are no Archie servers still online, and all that remains are ghostly remnants of a bygone era scattered across the web on forgotten web pages. And FTP itself is hanging on by a thread. Major web browsers no longer support the protocol, and once popular and thriving FTP sites are now shutting down. Which is a shame. We think such an important piece of internet history should be preserved. And so we've decided to try to run an Archie server ourselves. FTP was such a huge part of the 90s internet experience, and bringing Archie back seems like the perfect way to recapture that magic. But with Archie long since abandoned, we're going to have to figure out where to find the software. We first turned to Alan Imtaj with our idea.
There is a copy supposedly at the Computer Museum in, where is it, Palo Alto or?
Mountain View,
Mountain View, yeah. You might be able to try and get hold of them and see if they were given the tape of the last known tape of the source of Archie. But I never heard back from them on whether or not they were actually able to, extract
get it off
extract
the
it.
tape.
Yeah.
The Computer History Museum's collection contains over 150,000 items, and luckily it is searchable through their website. Aside from an information superhighway training video from 1994, there is nothing relevant here to Archie, so it could be that the tape copy that Imtaj provided was not recoverable. Finding information on the web about Archie's early days is difficult, since the Wayback Machine's earliest crawls are from 1996, several years after Archie's peak. We did find a record of bunyip.com from 1999, just before the company closed its doors. From this page, we found that Archie's last version was 3.5, and it was selling for $6,000, a one-time fee for an unlimited license. but there was a discount for educational institutions. We also found a listing of Archie servers from 1997 and up through 1999, but none of these servers are still online. Their telnet interfaces have been shut down now for most likely well over a decade. So where does this leave us in our search? Well, there aren't going to be any easy answers. If we're going to find Archie, we're going to need to scour the corners of the web and the last remaining vestiges of the early internet. As you might imagine, a popular service like Archie spawned several other projects that aim to expand its access and make it easier to use. So we thought starting there might get us some leads of where to find Archie. The first we found was an Archie client for the Macintosh called Anarchy. It did away with the need to connect to Archie servers through a command line telnet client, and instead provided a graphical user interface along with a built-in FTP client for easy file downloads. We found a contact for the program's creator, Peter Lewis, and amazingly, he responded with an old Archie server listing, query code, as well as the transcript of an actual Archie session. But Lewis did not have a copy of Archie itself. We then found the creator of Archieplex, Martin Koester. Archieplex was a World Wide Web gateway to Archie servers that allowed users to query different Archie servers from a web browser, and the CGI form interface is still available to see, but with no Archie servers left, it doesn't actually work. But again, we hit a dead end, as Koester did not have a copy of Archie itself. We then turned to a Facebook group for internet old-timers, self-deprecatingly called the Internet Old Farts Club. If anyone knew where to find Archie, we thought they'd be here. Many in the group did remember the impact that Archie had, but again, we turned up empty-handed for an actual copy of Archie. After more weeks of searching, we were beginning to think this might be a wild goose chase for something that has simply been lost to time. But the fact is that little remains of the early internet. Even at its peak, there were under 100 Archie servers worldwide. And despite a thriving ware scene during the 90s, the server software wouldn't have had much value to individual users, so it's unlikely to have ever been pirated. But still, it seems unbelievable that there's not a copy of Archie still somewhere out there. With all of our leads exhausted, our last-ditch effort was to try to find and contact the old administrators of Archie servers. But we had nothing to lose, so we started at the top of the list. This ended up being an arduous, weeks-long process of using the Wayback Machine to find clues as to who ran the Archie server, and then investigating to see if we could find their contact information. And this seems like a 1 in a million shot. What are the chances that any of these universities or institutions would still have a backup of Archie from over 2 decades ago? Amazingly, we ended up receiving a few replies. The IT help desk at Rutgers University here in the US ended up tracking down a former network administrator, Dan Reisman. He oversaw the Rutgers Archie server in the late 90s. During the period leading up to their Archie server shutting down, it had seen very little usage. It had been running on a SPARC Station 20 named Dogbert, which was finally decommissioned sometime in 1998. Prior to that, though, it had been the largest Archie server in the world. But striking out again, all the backups had been lost. And more weeks went by with no leads. But then, we received an email reply from a systems administrator at the University of Warsaw in Poland. Amazingly, their Archie server had been aligned with an old database until sometime in 2023 when it was decommissioned. But more importantly, they had discovered a backup of Archie files, and in them, the actual Archie source code and binaries. We found it. Against all odds, all that effort and time searching for Archie had finally paid off. These were almost definitely the last copies of Archie still in existence. Somehow, this relic of the past had been found, and with Imtaj's permission, we set out to resurrect Archie. Well, here we are, possibly some of the last copies of Archie still in existence. The files we received consisted of 4 tarballs, a README, and a PostScript file. The README provided a list of files and their contents. There are backups of their server taken in 2011 and in 2021, as well as 2 tarballs of the source code, and one looks like it was a failed compile attempt. The PostScript file is a topology of Archie servers from 1995, showing how data gathering was distributed around the world. The first archive we took a look at was the source code archive. In the doc directory, we found an install doc which reveals that this is a beta of version 3.5, the final version of Archie. And in the manual directory, we found a complete LaTeX-based manual which we've converted to HTML using Pandoc, and we've published it in its entirety on the Serial Port website, with a link in the description below. From the docs, we discovered that one of the most important differences in the later versions of Archie was usage of something called the Prospero Virtual System. Prospero was created in the late 80s by Clifford Newman at the University of Southern California. It's a virtual file system, and this version of Archie uses a modified Prospero server and protocol to efficiently handle user queries, rather than the more resource-intensive grep string searches of the earlier days. And after some more exploring around in the other archive files, we may have hit pay dirt. We stumbled upon the dist directory in the university's backup from 2011. It looks like it contains the original distribution files for Archie. With these, we should be able to do a clean install. So let's get started on bringing Archie back into the 21st century. We first created a QEMU virtual machine to emulate Spark hardware, and then installed Sun OS version 5.6, as this will serve as our platform for Archie. From there, we simply follow the instructions from the install doc. First and foremost, it starts with the user requirements on the system. It requires that 2 users are created, Archie and Arch user. But confusingly, both need to have the same user ID, which we can't seemingly do with the user add command. However, we did find an option of -O, which allows a user to be added with the same ID. Second, there needs to be a user group added called Archie, and both users need to belong to it. Once that's done, we can move on to the files required for installation. We see the base archive, install archive, as well as the specific SunOS 5.4 files that we need. We also have the unwrap, untar, and unrotate scripts as well. It looks like we simply run unwrap to begin the install process. That was fast, but we encountered an error of rel undefined variable. Editing the unwrap script, we can see that because we're using SunOS 5.6, there is a version mismatch. We hard code the rel variable and restart the install. And now we're ready to run make, except we don't have make installed. After quickly doing that, we can now successfully run make. The install is done, so we've reached our first goal, but now it's time to start the configuration. To get Archie configured, the documentation indicates we should first set something up called the pseudo domains database. This allows top-level domains like .uk or .au, for example, to be segmented into defined regions of the world to make it easier for users to search FTP sites that are close to them geographically. In our case, that won't matter, so we'll just go with the default specified in ardomains.cf. And then we run the ardomains program in the bin directory to create the database. Next, we need to add a line to inetd.conf for the AR server process. And after that, we add a line to etc services for AR server as well. We then need to modify the arretrieve.cf file to update the timestamps. We changed these from 1994, over 30 years ago, to the current date and time. And then the arupdate.cf file specifies which Archie servers we will do a data exchange with, which Alan Emtage, the creator of Archie, explained.
When there were multiple Archie servers, there was a whole system of exchanging data between the Archie servers. So that was Archie 3.x, 3.0. When we sort of made it commercial and all that. And so the world was basically divided up into either by domain name or, well, always by domain name, but domain names could either be country-based or functional based. So you could have, an Archie server would be responsible for all the Korean sites, and it would collect all the data for the Korean sites. And then there was a process where it would package all of that up, and other Archie servers would connect to it and say, give me all that data. So it was sort of pre-digested data they would then have, and they could then distribute that to other Archie servers.
In our case, though, since this will be the only Archie server in the world, we'll just remove the bunyip.com entries for now. And we're finally ready to add an FTP site that we want to index. To do so, the docs recommend using the host manage program that's included with the installation. It's a curses-based program that uses Emacs control commands. Pressing tab brings up a menu, and we press 1 to add a new site. We're specifying hobs.serialport.org, our mirror of the OS2 Hobs archive that was recently shut down. For the operating system, we get a choice of unknown, Unix BSD, VMS Standard, or Novell. Great. We'll just leave it on Unix BSD for now. We also need to add this to the anon FTP catalog, since this is an anonymous FTP site, as opposed to the web index or another custom catalog. We're then asked for a file name, but it's not clear what this is. Does this mean the file name of the database entry or a file name on the FTP site? We just enter the host name for now. We change the status to active and then save the entry by pressing Ctrl-U. We weren't sure what to do next to get the FTP site updated, so we consulted the cron tab entries from the University of Warsaw installation. We ran several of these commands with seemingly no activity, until we saw the archie.log file entries where it complained about an empty arupdate.cf, which is the file that we removed the bunyip.com lines from. Oops, we restored that and tried again. Running arretrieve with the -l option does produce something in archie.log. We see that there is a connection to localhost, but other than that, nothing else. So we then used Truss, a debugger for Sun OS, to see if we can get any more information from arretrieve. We do see that it is opening and creating files, and it does appear that it is updating the date and time in arretrieve.cf, as this file is now set to April 24th. We then find out we can use the -f option to specify a hostname to manually update. And finally, some progress. We have a header file written out to the disk, which is used by the next process to actually connect to the FTP site. And then we stumbled upon a sentence in the docs that states that we can use the -v flag on most commands to get a more verbose output. So we run arcontrol-r-v, which runs the retrieve anon FTP program. And oops, we can see that it's trying to download a file named hobs.serialport.org. This is what the file name field in host manage must control. So going back into host manage, we can update the entry and remove that value. Running arretrieve again and then arcontrol, we have what looks like success. Archie connected to the FTP and retrieved a recursive listing. The next step in the process is to parse the output generated by arcontrol-r. So now we use the -p and -v options and encounter our next error. We're seeing more file not found errors. Manually running the command at AirDawn reveals the problem. We don't have Perl installed. After getting that installed, we figured out we have to rerun the indexing process from the beginning. And now we run arcontrol with -u to update the database. And once that is completed, we see now that there are string files indicating that we should have a searchable database now. Archie comes with several built-in clients, including a telnet client. We fire that one up and change our search type from exact to sub to allow partial matches from our query. But we get an ARDP timeout. It turns out that the Prospero server needs to be running for the telnet client to work. So after starting that and trying again, we now get a super helpful error message. We honestly weren't really sure where to turn next, so we decided to just give it another try. And lo and behold, it works! Our new Archie server is now fully up and running with a searchable database. We can even use remote clients to query the server. And after indexing a few more FTP sites, we've got plenty of data to be able to search. And finally, we can say that Archie is back. We've achieved our goal of bringing Archie back. But Archie was meant for internet users, and that's where you come in. We've opened our Archie service to the public at archie.serialport.org. The interface is based on Archieplex, the web gateway we talked about earlier. And we were surprised to see that Archie could actually be somewhat useful in the modern day. The listings are hyperlinked, so if you have an FTP client set up for your browser, it enables pretty quick and easy file downloads without needing to wade through a bunch of web pages to find what you're looking for. And with Archie now up and running for the 21st century, our journey is now complete. When we started this project, we had no idea if we were actually going to be able to find Archie. So we owe everyone who helped us out along the way a huge thank you, and especially to Mike Schwartz and Alan Emtage, of course. And thank you for coming along with us, and we'll see you next time. The ISP series is back, and today we're taking the next step in building out our retro dial-up ISP. We're looking at a technology called Radius, an access control protocol critical to ISPs in the 90s, and one that's still being used today. We talked to Brian Lloyd about how Radius was born out of frustrating necessity, and with any luck, get it up and running on the portmaster for the Serial Port ISP. In the early to mid-90s, there was an insatiable demand for users getting online, which led to a boom of both walled garden online services like CompuServe, Prodigy, and AOL, as well as the small and scrappy independent ISPs. The frenzy of thousands of ISPs popping up created an entire industry to feed them with modems and all of the other supporting gear that they needed. But one of the most critical pieces was the choice of a terminal server. And no matter which one an ISP would pick, they would need to implement some form of access control for dial-in users, or what came to be called authentication, authorization, and accounting, or AAA. An early ISP such as ours would have started off handling user authentication with simple user entries in a text file, or as local users on a Unix machine such as the SunSpark Classic. But as an ISP grew, it would scale by using multiple terminal servers connected to banks of modems. And as we heard from Pete Ashdown in our first episode, running an ISP during this time was incredibly expensive, not just from an equipment standpoint, but the operating costs could be sky high. And so back in this era, it was extremely common to see ISPs across the US, both national and local, charge by the hour or even put in place time quotas for their users in order to make enough money to continue operating. All of this created a new problem though. Validating, managing, and tracking user accounts grew increasingly problematic and complex. During this time, some terminal server manufacturers met this need by offering their own proprietary systems for AAA. Cisco's TAC-AX dates all the way back to 1984, where it was used on ARPANET, and the increasing prevalence of these proprietary solutions meant that interoperability was slim to non-existent. Brian Lloyd, who we first heard from in episode 4, saw and experienced these issues firsthand.
Well, one of the problems was there was no centralized authentication capability. So I called a Birds of a Feather meeting at Interop, and I think this was Interop 92 or maybe Interop 93. Well, we got all the terminal server vendors, Zyplex, Cisco, Livingston, Telebit. We're getting all these guys in. And so we had BOF, and it was like, look, guys, we need a centralized authentication server.
And one of the key trends that was emerging around early internet development was this idea of open standardized protocols, instead of the more proprietary vendor-specific ones from like IBM or DEC. And so there was a growing appetite for an open solution for AAA.
Well, Cisco stands up and says, TAC-AX. Everybody's going to use TAC-AX, which was the original authentication protocol developed for the ARPANET. And then Zyplex had their own thing, all the rest of it. And so 2 hours of trying, the vendors being unmoving. They just said, no, we've already got a solution. We don't need a new solution. You just need to adopt our protocol. And we were very, very frustrated. So finally, after 2 hours, we pretty much gave up. And as the vendors file up, I'm sitting there, and up walks Steve Willems. And he said, what do you want to do? Walked up to the whiteboard, and we started working on a protocol.
Steve Willems was the CEO and co-founder of Livingston Enterprises, makers of the Portmaster terminal servers. Willems took their idea from Interop and developed it into a fully fledged protocol that would be called Radius, which stood for Remote Authentication Dial-In User Service. The idea of Radius was to centralize authentication, authorization, and accounting for users, or in other words, help infrastructure answer 3 questions. Who are you, which is the authentication piece? What services am I allowed to give you, which is authorization? And what did you do with my services while you were using them, which is the accounting part. When an ISP expanded from more than one terminal server, they would have to figure out a way to synchronize AAA data, like username and password values, time spent logged in, and so on between the terminal servers. This led to confusing and complex scripts that attempted to automate the process. Radius provides a standardized way of handling this information. The Radius protocol uses UDP to transfer packets that are made up of 4 header sections and a payload supporting over 50 attribute value pairs. The header consists first of a code, which defines what type of Radius message is being sent, like access request, for example. Then an identifier, which helps with threading and linking of requests and replies, a length value, which is just the length of the packet itself, and finally the authenticator, which contains values that allow the Radius server to verify identity of the server requesting access and to decrypt passwords sent in the payload. And the payload contains attribute and value pairs like username, password, and many other attributes like session time and so on. And at least in an ISP, there is typically a server running Radius software, which we'll talk about shortly, that responds to Radius requests. So for example, when a user connects to an ISP, it would trigger a Radius request from the terminal server that the user connected to. The request itself would have the access request code in the header of the UDP packet, and some attribute value pairs in the payload like username and password. The Radius server would then respond with approval or rejection of the request after accessing the user records in a database. So if you've used all 10 hours of your allowed ISP access for this month, you're out of luck. Livingston's new Radius protocol would have one of its first implementations at MishNet. MishNet was a regional network and ISP in Michigan that was connected to the wider NSFNet. It was operated by nonprofit Merit Network Incorporated, and in the late 1980s, they needed to convert MishNet from a proprietary network protocol to IP and transition to standard commercially available terminal server equipment. They awarded a contract to Livingston for Portmaster hardware, as well as their newly developed Radius server. Using Radius as a base foundation, Merit Network then expanded upon it and built their own Radius server with more features. And in March of 1993, Willans presented Radius at the 26th IETF meeting in Columbus, Ohio. The Radius protocol would then become an internet draft at next year's meeting in Seattle, kickstarting its route to becoming an official IETF standard. Carl Rigney of Livingston described Radius as being deliberately designed to be simple and extensible, meaning the protocol could be easily expanded upon in later versions. Radius was open source from the start, so while it was making its way through the standards process, it was rapidly adopted, especially in the ISP and terminal server industries. And in January of 1997, the initial Radius RFC was issued by the IETF, with the latest version in RFC 2865, which was released in June of 2000. But that wasn't the end of the story for Radius. Radius has continued to grow and evolve over the years, and is still in use today for lots of modern technologies. Modern enterprise Wi-Fi solutions make extensive use of the Radius protocol, which, when used with 802.1x, provides port-based network access control, and it integrates seamlessly with backend systems like LDAP, Active Directory, and multi-factor authentication services. While Radius has been a huge success story, we wanted to go back to its roots, helping manage dial-up user access, and our Portmaster-fueled ISP is the perfect place to do that. We started out by searching for the earliest version of Radius we could find, which ended up being version 1.16. The install file shows this is dated January of 1995, so a few years after Radius was first introduced with Mishnet. We're going to see if we can install it on a modern Linux host. We're working on our Ubuntu 22 lab machine with no serious expectations of getting this now 3-decade-old software actually working. After creating a Radius user and extracting the tarball, let's take another look at the install file. It looks like we'll first need to add these Radius ports to our etc services file. And then make the directories for the Radius database and accounting files. Now we populate our ADDB data, copying the example clients and user files. And here's the client's file. We're adding localhost as a first test to query Radius from. And looking at the user's file, it has some predefined users with different configuration examples. So let's try out the Steve user to start with. We try to compile the code, but we get this error of undefined reference to crypt. We then found we can add -l crypt to libs in the makefile to fix that. We now have radiusd, but there's not much helpful info from the command line. We can run it with -x though to keep the process in the foreground and get debug output. Radius comes with this radpass command for changing user passwords, so we want to use that to test a Radius server. What happens at first though is that while the server receives the request, it just hangs and the client itself is stuck. After looking at the code, we found the radrecv or receive function receives the request and passes it to radrespond, where we can see the pass change macro must be defined for the password change request to be called. Oddly, pass change was not defined, so we added it to the makefile and then rebuilt and restarted the Radius server. After verifying the existing password, a second attempt of radpass seems to be successful. However, note the warning about received invalid reply digest from server. So now let's log into the Portmaster.